right, so now let's look at a probability the song is positive, negative, or neutral. So, looking for the probability the song is positive or negative or neutral. So how many songs were positive?
178.
178. How many songs are neutral?
128.
128. And how so many songs are negative?
71.
71. So all I can do is add those three numbers together. And I find my probability. Oops. So that would give me the 71 plus the 137 plus the, I already forgot the numbers, 178. And that actually will add up to 375, 377 out of 377. And that's a really bad mathematical way to write that. So let me fix that. That's a better way to write it. Okay. So what is 377 over 377, by the way?
1.
That's 1. Okay. All right. And I'm not sure I had the right numbers there, but let me get the right numbers. It was 71 plus 128 plus 178. Okay. I just want to make sure I had the right numbers there so you didn't get confused of where they came from. So 71, 128, and 178. Okay. All right. So I want to do a couple more songs, a couple more things. I want to know what is the probability a song is about a Republican? So going back to my table here, what's the probability the song is about a Republican? So that means we need to know who the Republicans are, right? So does anybody know who the Republicans were in this election?
Donald Trump.
Donald Trump was a Republican. So we have the 268 from him. Who else?
Christie and Cruz.
Christie and Cruz. So we have the 2 from Christie and the 1 from Cruz. Anybody else? Ben Carson was, and so was Jeb Bush, and so was Mike Huckabee. So a lot of them. So that's 10, 12, 14, 15 plus the 268. So 15 plus 268 is what we're looking at here. Out of the 377. So again, I can add those up. 283 out of 377. All right. So now the question is, what's the probability the person is not a Republican? So going back to my chart, who was not a Republican?
Sanders and Clinton.
Yeah, Bernie Sanders and Hillary Clinton. So that would be 92 plus 2 is 94. So the probability of not being a Republican would be 94 out of 377. Okay, cool. So now what I want us to do is I want us to come up with a few rules that we might have that we can kind of look through and see what we come up with. So what do I want you to notice about all these probabilities? Every probability we found, what's the smallest probability we found in all these probabilities we found? And what's the largest probability we found in all these probabilities we found? So look through your list, see what's the smallest number and what's the biggest number.
Zero and 1.
Yeah. So the smallest number you're ever going to get, whoops, wrong place, is 0. And the largest number you're ever going to get is 1. So that's one thing to realize. If you get a probability that's negative, you did something wrong. If you got a probability that's way more than or just above 1, you did something wrong. So make sure you look at that and see what those would be, because they're always going to be a number between 0 and 1. The next thing is I want us to look at is the probability of all outcomes in a sample space must add up to a certain number. And so I'm going to go back to that problem I said I want you to think about here. Back here where we were looking at this, and I said that here's the probabilities of all of these outcomes. And what did the total come up to? 1. So the probabilities of all, oops, wrong page. The probabilities, if you add up the probabilities of every single outcome in your sample space, it will always add up to 1. All right, and that's going to come important in a later chapter. All right, so now we're also going to do a couple other definitions. Another definition is something called a complement. The complement contains everything in the sample space that's not in the event you're dealing with. The symbol for it is A with a C on it, or just say not A. And I like the not A because it makes more sense to me. So what I want to do is, can you tell me for sure that a song about a Republican and a song is not about a Republican are complements? So if I go back and look at my sample space here, here's all of my candidates. If the song is about a Republican, remember the Republicans were Ted Cruz, Mike Huckabee, Jeb Bush, Donald Trump, sorry, Chris Christie, and Ben Carson. If you look at those people, would you say that the people who are not them is everybody else? So if you're not one of those, who are you? So if you're not a Republican, who are you? Who are you? Or I should say, if the song's not about a Republican, who are you? Who's the song about?
A Democrat?
It's about a Democrat, or at least against somebody else. It doesn't necessarily have to be a Democrat. Bernie Sanders, before this election, actually was an independent. Hillary Clinton was a Democrat. So if it was not about a Republican, it's about these two. And together, if I put them all together, they would make up the whole sample space, but they are separate groupings. So Bernie Sanders and Hillary Clinton is very different than Ben Carson, Chris, Donald Trump, Jeb Bush, Mike Huckabee, and Tom Cruise. So they are, in fact, definitely complements of each other, because if you're not a Republican, if the song's not about a Republican, I should say, then it is about all the others in the group, in the list. So therefore, it is definitely that way. What I want you to think about, and I might go backwards, see, what is the probability of a Republican plus the probability of not a Republican? Obviously, I can't spell Republican. Repub. I still can't spell Republican. There we go. Finally got it. Okay. I'll fix it over here too. All right. So if I'm going to add those two together, remind me, what was the probability of being a Republican? We did that just a little bit ago. If you wrote it down, you can just tell me what it is, or I can go back and look. Anybody remember what that was?
Is it just one?
Well, it will. I want you to show that it's going to be one. Yes, it's going to add up to one. So probably Republican, remember, was 383 plus 370 over 377. Plus, and the probability of being a not Republican was 94 out of 377. And I don't know who just said that. I think it was it Isabel? I can't remember who just said that. But as you notice, if I add these two numbers together, I do get 377 out of 377, which is 1. So I want you to realize that if you add two complementary events, probability of two complementary events together, you will always get 1. And the reason we do this is it allows me to, in general, figure out how do I find the probability of a complement if I know the probability of the other event. So if I want to find the probability of not A, and I know the probability of A, how can I find the probability of not A if I know the probability of A? So I want to kind of come up with some formula here that will let me find, if I know this one, the probability of A, how could I find the probability of not A if I know the probability of A? As an example, if I tell you the probability of passing this class is 70%, what's the probability of not passing this class? Or the probability of it snowing today was 100%. What's the probability of it not snowing today?
Isn't the total of the probability?
Yeah, what's the total of the probability?
1 or
1.
100?
Yeah, so it's 100%. And what am I going to do to get the probability of not A? If I know the probability of passing the class is 70%, what's the probability of not passing the class?
70%?
It's 70% is passing. What's not passing?
Oh,
30.
30%?
Yeah, because you subtracted that from 1. So if you want to find the probability of not A happening, all you do is subtract 1 minus the probability of A happening. So this is known as your complement idea. And you know this, you actually knew this, you actually could have told me this if I didn't ask it in such a weird way. If I just ask you, like I said, if the probability of it not snowing today was 0%, you could have told me that easily without doing any of this. But this is the rule we kind of use for complementary events. If you know the probability of one event, the probability of its complement is always just 1 minus that event. All right. Another song, another problem I want you to look at is I want you to look at the probability of a song about Ted Cruz. Let's do Cruz. Plus the probability of positive. So let's go back and look at that separately. We did the probability of Ted Cruz. It was on this page. What was the probability? No, it was on this page. What's the probability of Ted Cruz? A song being about Ted Cruz.
One over 377.
Okay. So I'm going to put that on the page I'm on right now. And I'm going to add that to the probability of it being just positive. So what was the probability of a positive sentiment? I know you can all see it, so I'll just grab it. So what do those add up to?
$179 over 377.
Okay, 179 over 377. Great. Thank you, Dorothea. All right. What I want us to do now, I want us to do the same thing. I want us to look at the probability of a song about Donald Trump. Plus the probability of it being about a negative. So again, go find out what is the probability of a song was about Donald Trump. We're going to go grab that number. And we're also going to grab this other number, negative sentiments. I'm going to add those two together. And the negative one, I just saw it and then totally forgot what it was. So I'll have to go back. Negative one was 71 out of 377. And what do those add up to? You all have calculators because you all have phones. So can somebody tell me what that adds to?
339. 339 over 377.
What is it again? 370,
339.
339 out of 377. Okay. Thank you. All right. What I want you to notice is we did the probability of Trump and negative, and we did the probability of Cruz and positive. But we did the probability of Cruz and, well, here's Trump and negative. That's and negative. Let's do or. We did a probability of Cruz and or positive, and we got 179 over 377. We did the probability of Trump or negative, and we got 305 over 377. So notice, and you probably can do this easier than I do because you've got it on your, you can just look on the different pages. But 179 over 377 was true Cruz and positive. And notice that's what we got when we added these two together. When I added probability of Cruz plus probability of positive, I did get 178 over 377. I got that exact same number we got when we did the or statement. However, when I added Trump and negative together, I did not get the same answer. If you look back here, the probability of Trump or negative is 305 out of 377. So why, in one case, did I get the same answer when I added them together, but in the other case, I didn't? So in this case, when I added them together, I get the exact same answer I got when I did the or statement. But in this case, I didn't. Anybody have an idea why?
Is that because we didn't count that 34 negative?
Yeah. Yeah, exactly. Exactly why. It's because we counted, in one case, we counted, in this case, we did it here, we counted the 34 twice because the 34 is in this number and it's in this number. So we counted that 34 out of that Trump and negative twice. We counted those 34 twice. We counted the song about Trump and positive, and negative, sorry, negative, twice when we added them together. And that's exactly why we did that thing twice. But in the first case, we didn't have anything to add twice. There was nothing overlapping. In this case, there's nothing overlapping Cruz. There were no songs about Cruz. There were also songs that were positive. But in this case, there was overlap. There were songs about Trump, and there were songs that were negative, and they overlapped. So that was the biggest problem, is that we had some overlap. And there's a name for these things. And we're almost at time, so we'll be able to finish this piece up, and then we'll have to do the last thing next time. So there's a name for this. This is what we call mutually exclusive. Some people call it disjoint. I hate disjoint, but I don't know if I like mutually exclusive either. But I think of them as they mutually exclude each other. So if one happens, the other one can't. And if the other one happens, the first one can't. So they exclude each other is the way I like to think of it, and it's mutually done. So mutually exclusive events are events that cannot happen at the same time. So looking back at this situation that we have, can you tell me some other events that cannot happen at the same time, that are mutually exclusive? So can anybody see any events here, any outcomes here that cannot happen at the same time? So I'll give you a hint to think about. Can Ben Carlson and a song of being negative happen at the same time? So Ben Carson. So a song about Ben Carson and a song being negative, can that happen at the exact same time?
No.
No, because there's nobody there. So can you give me some other ones?
A neutral sentiment towards Bernie Sanders.
Yeah, notice Bernie Sanders is here, neutral's here, but there's no songs about Bernie Sanders that are neutral. All right, anybody else? Let's do one more.
Bush and a positive sentiment.
Which one? Sorry, Isabel.
Jeb Bush and a positive sentiment.
Yeah, so here's Jeb Bush, here's positive, but there's no things there. So all of those would be not happening at the same time. All right, so some different situations we came up with was Ben Carson and positive, Bernie Sanders and neutral, and Jeb Bush and positive. So all of those were mutually exclusive because they can't happen at the same time. So can you then, looking at that idea, can you tell me if two events are mutually exclusive, can you tell me what's the probability of both of them happening at the same time then? That would be what and would mean. And would mean they happen at the same time. If they're mutually exclusive, what would be the probability of them happening at the same time? So going back to this, we looked at this. We said Ben Carson and negative was was mutually exclusive. So what was the probability of them happening together? Oh, and actually it was negative, not positive, sorry. So it'd be 0 because they can't happen again at the same time. Anything that can't happen at the same time are going to have a probability of 0. It's impossible for that to happen. So if it's impossible for something to happen, it will not happen. By the way, if the probability of something happening is 1, like it was 100% chance it was going to snow today, what happened? So if the probability of something
The
is 100%,
probability of one.
it probably is 1. And if it's wonder if it's 100%, what does that mean is going to happen to it? What happened today?
So
It snowed. So if something has a 100% chance of happening, it will happen. If something has a 0% happening, it will not happen. So the probability of A or B would be just adding the two probabilities together if they're mutually exclusive. I know we're almost out of time, but I want to just do this one last thing. And the probability of A or B, if they're not mutually exclusive, you add the two probabilities together, and then you subtract off the overlap, which is what we saw. So you would subtract off that overlap, and then you get your probability. I don't use these very often. I usually just count things and look at the numbers and not worry about using these, but you can use these. All right, we're done for the day. We're going to finish this next time. And then we're so hopefully we'll see everybody Monday. If not, just keep looking for emails from me. And I didn't bother to take attendance today. I am recording this and I'll post this.